Hi, I'm Tim and welcome back to this Alta Labs Home Lab setup series, and this is part 3, and in this video we're going to be setting up this, which is the Alta Labs AP6W wall mount Wi-Fi 6 access point. So what we'll do is first we'll take a look inside the box here, go through a few of the specifications, and then we'll get it set up into the Alta Labs Cloud Controller. And then what we'll do at the end of this video is we'll take a look at some results, what I've got for the transmit and receive speeds for the Wi-Fi link up between my PC here behind me and this access point. But in the meantime, we'll take a look inside this box, take a closer look at the specs, and then we'll get it set up into the Alta Labs Cloud Controller. So keep watching and we'll get right to it now. And here we are with the box. It's nice, compact, simple packaging, plain packaging apart from the writing of course on it, so you can easily recycle the packaging. On the back we get the label which says AP6W and of course the serial number, and also the barcodes and all those details. So inside the box we have two mounting plates. Now one is shallower than the other, so let's just take a look and I'll show you what I mean. So we get these, which are two side by side. You'll see that one is actually slightly deeper than the other one. Now the shallow one is actually for putting it on a mounting wall box. So for example, if you've got a wall box already in your wall and you've already got a Cat6 or Cat5 or Cat cable connection to it, then this would be replaced with the actual mounting plate of your wall plate. So you take your wall plate off and then replace it with this one so that you can actually mount it on the wall. Now it's got various holes for different setups, so depending on what size mounting box and everything you're using, it should be able to fit that. So for the other mounting option, it is this, which is the deeper of the two wall mount plates. Now this is actually to fix it just straight onto a wall without any, for example, wall plate already being there. So what you would do is just mount this onto the wall. The access point would fit on the front of the cover, and then you could connect it via the two outlets, which I'll show you in a minute. So they would be connected from the bottom. Now it's nicely made, very well constructed, nice design. It's all metal at the back, and then at the front it is polycarbonate. So all this white here is actually polycarbonate, and then the metal at the back is aluminium. So it acts as a heatsink as well, because this does actually run quite hot. The access points are known for this, but there's no damage to the access point at all, so don't worry about that. So you'll see on the back we've got a port that sticks out of the back here, hence why it is for going onto, say, a previously existing wall socket. So that would be recessed into the existing wall box, and then that would fix on the back like so, so that you can actually mount it onto the existing wall box if you've already got one there. However, if you haven't, like I've just mentioned, then you can fix this flush to the wall, then the access point would sit on that plate there and it wouldn't actually obstruct with that part that sticks out the back at all. So it would sit flush onto the wall without having to make any indentation in the wall for this recessed part to go into. At the back you've got the PoE in. Now this is powered by PoE AF or AT, so PoE or PoE Plus, ideally PoE Plus of course. And also at the bottom we have 3 other ports. Now the one at the left is also PoE in, so you can either use the PoE in at the back or the left side PoE in at the bottom to actually power the device and connect it to your network. So the middle port is PoE out. Now be aware that this is actually PoE and it's permanently powered. So it's passive PoE for that port. So if you, for example, connect a device that doesn't want PoE into that, it could cause irreparable damage to this access point and also the device plugged into that PoE out port. So just make sure that whatever you plug into that PoE out port, that it can support passive PoE, such as, for example, a voice over IP telephone, which would be ideal for that PoE out port. Now the third port on the right hand side is for powering it via DC 12 volt. So you can actually power it via 12 volt DC power, and that is rated at 1.5 amps. So it's a nice looking access point. So onto the specifications for this. Oh, and also you do get, of course, the usual quick installation guide or quick start guide, and this tells you all the information you know, and there's also a QR code that you can scan there. And one last thing you do get is the wall plugs and also the fixing screws for the brackets. So for the specifications, the dimensions for this are 156.1 by 90 by 43.9 millimeters, which equates to 6.5 inches by 3.54 inches by 1.73 inches. Now the weight for this, now it does have a bit of weight to it, and that's with the aluminium backing, I would think, and it weighs in at 0.312 kilograms, which equates to 0.68 pounds. The top cover is actually polycarbonate and the bottom cover is aluminium, which acts as a heatsink as well. The mount is actually made of polycarbonate, so it's plastic mounts, but they are solidly built, really well built. So for the network interfaces, it can have Ethernet, Wi-Fi and Bluetooth. For the management interface, there's 3 gigabit RJ45 ports, so these are 1 gigabit ports here on all of these 3 ports. There is also a factory reset button there, which is recessed, and it does actually say reset next to it. For the LED, so there's an LED line at the front here, and that can either be blue or white colour depending on how you set it in the cloud controller, or if you're running your local controller, then depending on how you set it in there. For the PoE, it is 802.3 AF and AT, which I've just mentioned, and it is PoE or PoE+. The supported voltage range for this access point is between 42.5 and 57 volts DC, and the maximum power consumption is 14.2 watts. For the transmit power on the 2.4 GHz, it's 20 dBm, and for the 5 GHz, it is also 20 dBm. Now it supports SU MIMO, so that's Spatial Stream Single User SU MIMO, for up to 574 megabits per second, and that's with the wireless data rate with HE40 bandwidth to a 2.2 wireless client device under the 2.4 GHz radio. And for the SU MIMO on the Spatial Stream Single User MIMO, for up to 1200 megabits per second wireless data rate with VHT80 to a 2.2 wireless device under the 5 GHz radio. So the maximum throughput for this access point is on the 2.4 GHz, it's up to 574 megabits per second, and on the 5 GHz it's up to 2.4 gigabits per second. And I also should say that the Wi-Fi standards it supports is 802.3.11 B, G, N, AC and AX. So that equates to Wi-Fi 4, Wi-Fi 5 and also Wi-Fi 6. For the wireless security, it has WPA2 personal, pre-shared key, WPA3 personal, and that's SAE, and WPA enterprise with WPA2 and WPA3. For the SSIDs, it can have 8 per radio. So that would be, for example, 8 on the 2.4 GHz and 8 on the 5 GHz bands. It also supports, which I like, is zero weight DFS. So that means if you select, for example, a DFS channel when you're setting up this access point, you don't have to wait, say, 10 or 15 minutes for it to provision the DFS channel. it will do it sort of instantly. It will take a few seconds, of course, which you expect. It also supports hotspot functionality, and it can be scalable, so you can mesh these together. So what I'll do now is we'll get it connected up into one of the ports on my Alta Labs S24 network switch, and then I'll hop onto the computer and we'll take a look at the controller dashboard and get this device adopted. And then what I'll do is I'll show you me connecting the PC to the access point to make sure it works. And then I'll show you at the end of this video some test results, what I did with playing around with the Wi-Fi channels and also the Wi-Fi bandwidths, and what it had an effect on the speed and so on. So keep watching and we'll get onto the PC now. So here we are, and I've logged into the Alta Labs Cloud Network Controller and we're at the dashboard. So to add the AP6W, what we need to do is click on Network at the top, and you'll see that the new AP has already appeared with the Setup button next to it. So all we'll do is click on Setup and wait for the access point to connect to the network, and you will see that it's now showing as connected. Now the firmware is already up to date, as I've already updated the firmware. So at the moment we're on version 2.2N. So we have no name for this device. So what we'll do is click on no name, and then we'll call it AP6W. And now we've got the AP6W named. So what we'll do to set it up, and as you can see, it's already just appeared with the data status. So we've got data throughput going here, currently at 0 bits per second. So what it's doing is finishing setting itself up, and you'll see that it's also got some channels. So it's already applied channel 36 onto the 5 GHz band. So it's on the 80 MHz bandwidth at the moment. So in a moment it should also appear with the 2.4 GHz channel as well. So while we're waiting for that, what we can do is go in and configure the access point. So to do this, you would click on the icon next to the name here, and then this brings up the pop-up window, as you will see. So we've got AP6W on the 2.4 GHz, it's set to channel automatic, and for the bandwidth it's set to auto, and also for the 5 GHz here it's also set to auto. Now for the colours, we've got the devices all set as with the black icon colour, so that's fine. Now of course you can actually allocate them to different networks by using different colour coding if you want. So clicking on advanced, you'll see that we've got the 2 GHz transmit power is set to auto, and the 5 GHz TX power, so the transmit power, is also set to auto. Now at the top we can go to settings, and you'll see it's showing you the 3 ports on the actual wireless access point. Now you'll see by default we've got the blue colour port here, and we've got a little icon next to it, and that's showing that it's connected to the S24 PoE switch, and it's port number 1 on the switch. And then we have the other 2 ports here, which are the PoE pass-through port in the middle, and then the other one is the port at the back of the access point, the one that I showed you, which actually sticks out the back. So that's the other PoE import, which you can use if you want to. You'll see we've got VLAN set up, so it's in the default VLAN, and the network, it's set to DHCP. You can of course click the icon here, and as you'll see we've got static or DHCP, so you could actually set it with a static IP if you wanted to, and you'll see that one appears automatically, but we'll just leave it as DHCP. For the management VLAN you can of course change this, and then we've got for the always on, so enabling this will keep Wi-Fi broadcasting from this AP even if the internet goes down, so that's enabled by default. And for meshing, that is enabled by default. PoE pass-through is actually disabled by default. Now that is for security reasons, or rather safety reasons, so that you don't accidentally plug something into the PoE pass-through port that doesn't require PoE, of course. Then you might cause irreparable damage, and it does actually warn you about this, hence why it's got a red question mark against it, which means that it's important that you read that information in the pop-up, as you'll see. So it says this forces power to be enabled on the PoE output port at 48 plus volts. Ensure that your connected device supports this before enabling. Improper configuration could cause irreparable damage, voiding both this AP and the connected device's warranties invalid. Then we move down to the LED, so that's by default set to default, which means that it's actually setting the colour of the LED via the settings, which I'll show you in a moment. You see we've got radius and we've also got temperature. So as I've said, these run quite hot, which is okay, and it's fine to use them like this. So it's running at between 59 and 59.2 centigrade. Now it is actually hot here in the UK at the moment, so it is actually hot in this building here where I am. So then if we click traffic, you'll see that we've got a graph, which is a live graph showing you the data traffic between the S24 PoE and this access point. And then we've got advanced. So if we click advanced, we've got priority, location, and you can actually reboot the access point should you so wish. So if it, for example, fails for some reason and you're in a remote location, you can actually reboot the access point if you want to. So then if we click on the info tab, here you could do a Wi-Fi channel scan. You can do a quick scan or full scan depending on how long you want to wait, basically. So the scanning should take between 5 and 15 seconds and it should not interrupt your Wi-Fi network. So we don't need to do that at the moment, we'll just move on. So we'll close this window, and then at the top if we go to settings, and then here you'll see we've got no Wi-Fi network. So what we'll do is first go into the settings tab, and you'll see that we've got the access point LED colour. So I've turned that off by default, so we'll leave that as off. So that's where you can actually control all of the LEDs on all of your access points in one go. Rather than actually setting them individually, you can just turn them off here and it will turn the LEDs off on all of them. So we'll go back to Wi-Fi, and what we'll do is just go to add new. So we'll create a new Wi-Fi network. So in the SSID name box, we'll call this AP6W. So AP6W is the name of our Wi-Fi network. And then what we'll do in password, we'll create a password. However, if we click just under passwords on the show more tab, you'll see we've got various types of networks. So we've got standard, which is a typical network with fewer than 100 Wi-Fi devices. Large is optimized for hundreds to thousands of Wi-Fi devices. And IoT is restricted to internet and local incoming connections. For the internet, we've got restricted to internet only. So that's if you want to just allow internet access and not access any of your other network devices, for example. Or we've got guest, which is restricted to internet and IoT devices only. So in this case, for this example, we'll click on standard. So we'll set it to standard here. So here's where you set the Wi-Fi network to the various categories there. So we'll set it as standard. And then in the password box, we'll create a password. And then once we've typed that in, we'll go down to sites, and it's going to be allocated to the home base site, which is this one at the top here, and which is connected with all our devices. For the color groups, as I said earlier, we'll set this to black, which is for the rest of the devices, but you can actually change that if you want to change it to a different group. So for example, colors are a way to group specific APs together. APs will only broadcast those Wi-Fi networks that match their configured colors. So both APs and Wi-Fi networks can be part of multiple colors and groups. So now what we'll do is click on save, and then this has now saved our wireless SSID network. So we'll go to the top and click back, and now you'll see we've got a Wi-Fi network set up. And then if we go back to the top, we select network, you'll see that the now AP6W is broadcasting on channel 36 and channel 6. So 36 on the 5 GHz and channel 6 on the 2.4 GHz. Now the 2.4 is set to 20 MHz bandwidth, and the 5 GHz is set to 80 MHz bandwidth. So what I'll do is try to connect this PC now to this Wi-Fi network. So if we go to network at the bottom, we'll select and enable the wireless network and select the wireless SSID, which is AP6W. Click on connect, and then it's saying that it's now connected. So we'll click the I information button, and you'll see that we've got the connection with an aggregated link speed of receive at 286 megabits per second, and for the transmit is 154 megabits per second. Now I have done previous tests, various different scenarios, and I managed to get different link speeds. Now the most I got, which I'll show you in a moment in the table, and with the various settings, I found that it worked better to not set the access point to automatic channels, but to set the information to manually, which is always what I've done with all of my access points from various different brands. So all the brands of access points that I've used, I've always set them to manual channels and manual bandwidth, and I found that they work a lot better and the link speeds are also a lot better. To manually set the information for this access point, we'll click on the icon, and then for the channel, for example, we'll select, say, channel 9 for the 2 GHz, and the bandwidth we'll set that at 40, and then for the 5 GHz we'll select channel, for example, 128, and we'll set the bandwidth at 160 MHz. And then what we'll do is click on save, and then for the advanced we'll select that, and for the TX power, so for the 2 GHz we'll set this to high, and for the 5 GHz we'll also set this to high, and then we'll click save again. Now that has then saved the transmit power for the 2 and the 5 GHz to the highest possible for this access point. We've set the 5 GHz to channel 128, which is a DFS channel. The bandwidth is set to 160 MHz, and for the 2 GHz we've set it to channel 9 and set the bandwidth to 40. So if we close this, and then we try and reconnect the PC to the AP6W SSID, click connect, and you'll see that it's reconnected that quick. So it is actually a quick access point. All the settings you change do actually occur very quickly with these Alta Labs equipment, and I've noticed that they are very quick. As soon as you set it, you can reconnect to that access point nearly instantly, which is a great feature what they've incorporated into their access points. So if we click the I information button, you'll see that we're now getting a speed of 573 megabits per second and 275 megabits per second for the aggregated link speed. For the receive here, 573, and for the transmit, 275. So that's a bit better than what we were previously getting with the settings at automatic. Now just to confirm, this wireless access point is placed behind my television, and it's in the next room to this current room that I'm in recording this video. Now the signal is going through solid thick brick walls, and the Wi-Fi USB dongle that I'm using is a TP-Link one. Now it's a TP-Link Wi-Fi 7 dongle. Now that is sat behind the PC screen, so it's behind my current PC screen at the side of it. And now here on screen you'll see that I've got the test results. So I did 9 tests in total, and you'll see, for example, that here we've got test 1. Now all of the time, so all of the tests apart from test number 9, we set the radio power to high for both 2.4 and 5 GHz. So for test number 1, we've set it to auto channel and it picked channel 6, and then for 5G channel it picked channel 36. The bandwidth was set to 20 MHz and 80, and those are the receive and link speeds we got. So I did the same for test number 2, but with different channel bandwidths and different channel numbers and so on. The best test I got was test number 5 and 6, as you'll see here, with the radio power both set to high. The 2.4G channel was set to either channel 6 or 9, and for the 5G channel they were set to channel 48. But for the bandwidth it was set to 40 MHz and 160, and that was with both tests. And with both those two tests I got 2401 megabits per second, so that equates to 2.4 gigabits per second on the receive and 864 megabits per second on the transmit. So now that we've taken a look at the access point close up, we've gone through the specs, we've accessed it and set it up into the Alta Labs Cloud Controller, and we've gone through the various settings and test results here on screen. So we'll end this video here, and hope you like this video, hope you found it useful, and keep a lookout with more videos coming again soon. And bye for now.